Hello, I'm Eric Pregler, and I'd like to welcome you to AST's first virtual event of 2021. We're attempting to hold at least one per month during 2021. We'll continue to experiment with online formats for connecting, learning, and building community. We'll also be watching the health and vaccine rollout situation closely over the next few months to see when we can start planning for in-person events again. Man, do I miss CAST. Speaking of which, we had a great program prepared for CAST 2020. One of the jewels hand-selected by Amanda Noble and Ben Simo for CAST is the talk that we're bringing you today. Not Your Parents' Automation, Practical Application of Non-Traditional Automation with Paul Grizzaffi. Like with CAST, Paul will deliver his talk, and then we will have facilitated discussion after that. Please post your questions in the chat. I'll handle the facilitation end after Paul's presentation. You can also comment and participate on Twitter with the hashtags ASTWebinar. And what's the one you're using for this talk, Paul? The automation one?
Oh, the automation assist.
Automation assist, which is I like a good way to I like how to talk about test automation that way. And the AST account is AST_news on Twitter. So the way many people in software development talk about test automation reveals a very shallow understanding of what automation is for and what it can do. The working practitioners I know, especially true experts like Paul, have a much more sophisticated understanding to share. I'd like to see what our community can contribute to these conversations and help us move beyond conversations about checking. But enough about that. Let's talk about Paul. Paul is a principal automation architect at Magenic, following his passion for providing technology solutions to testing QE and QA organizations. These include automation assessments, implementations, and activities benefiting the broader testing community. Paul is an accomplished keynote speaker, international conference speaker, and writer. He's an advisor to the software test professionals in STPCon, as well as a member of the Industry Advisory Board of the Advanced Research Center for Software Testing and Quality Assurance at UT Dallas, where he's a frequent guest lecturer. In addition to spending time with his twins, they are something else. Paul enjoys sharing his experiences and learning from other testing professionals. You can find his mostly cogent thoughts at responsibleautomation.wordpress.com. And now I'll turn it over to Paul.
All right. Thanks, Eric. Okay, let's get going. All right. So today we're going to talk about, it's not your parents' automation. It's not traditional automation. Just briefly about myself. Actually, I'm going to skip right over this because Eric did a great job of introducing me. And if you do want to contact me outside of this particular forum, here's my contact info, and there's my blog link at the bottom. And this will be up again during the questions section. So I'm not much of an agenda outline kind of guy. I'm more of a jump right in kind of guy. So when I say automation, what comes to mind? Well, I talk to a lot of people about automation a lot of times. And usually what comes to mind is scripts. I've got some scripts. How many scripts do you have? What are your scripts written in? Blah, blah, blah. And where do the scripts come from? Well, they come from test cases, right? We've got test cases and then we turn them into scripts. And to turn them into scripts, we use tools. So we got a tool and we take the test cases and we write the scripts in the tool. And now we've got some automation so that we can run regression testing. Because everyone knows regression testing takes this long time to do, and it's tedious often, and it's repetitive often, and boy, machines are really good at that kind of stuff. Because we want to save time, right? We want to save time of all this time that we do regression testing. So now I've saved all this time, and oh crap, maybe they don't need me anymore. If I've saved all this time and the machines are doing this for me, then maybe I'm going to get laid off. But nah, don't worry about it. It's a lot of work. I've been through these before. It's a ton of work to get this up and running, get it up off the ground. And it's always brittle. You know, that test case 47, that one breaks every time that we make a little change on the UI. And it's inconsistent. Test case 364 works most of the time, and every now and then it doesn't. So we just run it again, and if it passes, then we're good. So usually I would get people to raise their hand here. We're not going to fool with that today, but you can do it in the privacy of your own viewing center there. Raise your hand if you've said or heard these things, right? I bet everyone here has said and or heard most, if not all of these things. This is what typically comes to mind when we talk about automation in the testing realm. But to quote our friend Inigo Montoya, I think automation means something different. I do not think what the industry typically thinks that it means. But before we get too far into that, we'll talk about traditions. Traditional automation, test case-based automation, if you will, I poked a little fun at it, but it can be valuable. It's good at detecting behavior changes. It can reduce effort on smoke testing and regression testing. It can give us earlier execution of those tests, earlier alerts, and scheduled execution either on a time boundary or an event boundary, and helps reduce our opportunity cost in what it would take for us to perform those ourselves. Every company I've worked for and every client I've worked with now that I'm at Magenic, we've done this in some form or fashion, and it's been valuable because it can be valuable. But is there something else? Are we missing something? So what if we think a little differently about automation? What you see here is a picture of something called the Fortis exoskeleton. So this is developed by Lockheed Martin, and the idea is to allow a human to hold heavy, awkward, hard to manage physical items for much longer periods of time than they could on their own. So here we've got this guy holding a grinder, and I don't know very much about grinders, but I'm assuming that it's heavy and awkward, and I would imagine that once you put it on whatever metal you're grinding against, it probably wants to go its own way as opposed to the way you want it to go, and I'm sure it's pretty fatigue-inducing. Now, we're talking about Lockheed Martin here, literal rocket scientists. I bet they could invent a robot that could do the grinding for you. However, they didn't. They didn't think about how do we eliminate the human from having to do this job. They said, hey, why don't we build something that helps the human do this job? So instead of thinking about how to automate, what if we think about let's help the humans? And in this case, most of the time, we're talking about testers. How do we help the testers be more effective or more efficient at their job? Where's our value proposition? What hurts? Everybody's got some aspect of their job that sucks. You just do. Not every job, no job is perfect, and some are less perfect than others. But if we could, spray a little medicine on that pain, put a little machine help on some of the stuff that's not so fun to do, not so cool to do, we could go off and work on things that are more suited to human. So instead of automation, why don't we think about assistance? And this is where we start coining the term automation assist. And really, it's an umbrella term for non-traditional automation. I used to work for a guy named Patrick Amaku when I was back at a telecom company. And I know this is not really an original quote of his, but the way he would say it with his very deep baritone Nigerian accent is, Paul, words mean things. And they do. They really do mean things. And sometimes changing their meaning is difficult. So instead of fighting this quixotic war of, no, that's not automation, that's just an implementation of automation, automation's this bigger thing, we came up with a phrase, myself and a different boss came up with a phrase that allowed us to talk about non-test case based automation in a different format and without bringing the baggage of that extra or of the current definition around automation. And generally, automation assist can be clumped into three different groups of things. Off-label tool use, where in the medical industry, if you're using a medication off-label, it typically means that you are using it for something that it wasn't necessarily originally intended for, but it works for this other thing too. Like my mother-in-law has macular degeneration in one of her eyes. Well, she doesn't take a macular degeneration medicine. She takes a cholesterol medicine that, as a known off-label use, prevents any further degradation of her macular degeneration or slows it down such that that she'll be gone before the retina actually finally goes away. Sometimes we have to build new tools, new applications, new scripts, because what we're doing it's so particular for us, it's so specific in our context that there are no general purpose tools for it. So we have to invent something. And then sometimes we can use tools not traditionally used or not considered automation tools to help us with our testing and our automation. So let's look at some real examples of stuff that either I've done or people on my team have done throughout my career. So the first thing, we nicknamed this one MIRV, and MIRV is sort of a bleak acronym, but basically it's a missile that goes up in the air and then sends down individually targeted missiles from there. But we did some independently targeted testing using automation for this one particular project we were on. So the premise here is we're moving from one data center to another data center. It's to call it a migration is probably generous. It was more like an evacuation, but we're taking everything that cannot be kicked. Anything physical stayed, routers, machines, wires, racks, everything stayed except the bits and the bytes and the data. So we're moving ostensibly our largest and most complex product from one data center to the other. But fortunately, we had some experience from the year before when we did a test run of our second most complex and large product. And what we learned from that migration was we're not going to have off by one errors. The calculations aren't going to be broken. The system's basically going to work and we're going to get the data we expect, or it's going to be egregiously broken. It's going to be so broken that you can't route to the web server, or one of the databases isn't connected to the right subnet or something along those lines. So traditional regression tests would not be an appropriate fit here. Plus, the way this whole thing is set up, not only in the data is there the data for the clients, but there's configuration data. So it was less like having one product with 800 clients. It was more like having 500 different products, because we could go down even into changing menu items, in which order they were in and whether they were present or not. So what do? We created some scripts using the existing tool that we had in-house called Test Complete, and looked to find egregious issues. But we executed it simultaneously so that we would get a higher throughput and a lower duration of execution, but also in tandem with the testing that the testers were doing. And I'll get to that in just a second. So we didn't go through our normal regression test suite. What we did was we created new scripts to say, if I can get to this page, and then the next page, and the next page, and the next page, and then there's any data in this grid, then I know these 5 things are up and working and connected correctly. Because again, we're not dealing with off by one and calculation issues. We're dealing with ability to get somewhere or the failure to get to that place. And it took us several weeks of effort to get this to work. The scale was much larger than what we were running previously. So why do we go with this solution? The quick, shallow checks can maximize the human's time. So what were the humans doing? Well, for each, we did the migration in phases, the data migration in phases. So each time we did one of these migrations, we identified 10 to 20 mission critical, high impact clients, ones that paid us a lot more money, ones who had a recent outage, one who we knew that the data was going to be weirder. The testers focused on those. The automation did all the other ones, so that if we had an automation failure, then that would go into a tester's queue to say, hey, we had an unexpected behavior here. I'm going to need you to go and look at this as well as the other things you're doing. Using the existing tool reduces the effort, and we were able to count and capture between 7 and 12, because they do funny math sometimes, business critical incidents. And business critical incidents is where a client is unable to use any of the product or a significant portion of the product. And then a lot of VPs and a lot of really upset people get on the phone for many hours until these incidents are sorted out. And sometimes there are actual financial penalties that would have to be paid back to the client depending on the extent and duration of the outage. So certainly value was brought to the table here. The second example I'm going to go through was also created during this data center migration, and it's based off something called a high volume automated testing. So this is not performance or load testing. High volume automated testing is a family of testing techniques that enable the tester to create, run, and evaluate the results of arbitrarily many tests. So think about that for a second. Arbitrarily many. 1, 100, 1,000. I like to think of a lot of the high volume automated testing stuff as a crank, where what we're doing is we're getting the machine to turn the crank for us. And then in most cases, testers, humans, come in and check those results as opposed to looking for reds and greens and passes and fails. So high volume automated testing is also called HIVAT. So if you Google, there's not a whole lot of stuff out there, but there's some. Most of it comes from Kim Kainer, and there's some interesting stuff from Harry Robinson as well, particularly from his time at Google working on Google Maps. So for this particular organization I was working with, there were 3 of the facets of high volume automation that were very, very interesting for us. The mini executions, obviously, random execution, and the fact that the results are vetted by humans. So we invented something called SCUD. Sticking with our military theme, the SCUD is a missile who first kind of came into prominence in the 80s, largely because of its occasionally defective guidance system, where the missile would go off and in random directions. So the premise here is the product, the same one that we're moving. It's large, we talked about, complex, we talked about, and aging. It was not created with automatability in mind. It wasn't even created with testability in mind. It was created with, let's develop some software to help these clients do things, but testability, automatability, some of the other ilities along the way were not in the forefront of the minds at the time. And again, because of the configurability of the data, it wasn't really feasible to enumerate and follow all paths. We were following the ones that we knew about, the ones that we could think of, but we couldn't think of them all. And if we could, we weren't going to be able to hit them all in time. So did we just not do anything? No, what we did was we said, fine, we've got tests and scripts and stuff for the things we know about, for the important things we know about. Let's look for valid but unintuitive concerns, weirdnesses that we hadn't thought of, and then decide whether or not they're an issue. So we created this thing called a random menu clicker, and the whole product was kind of menu driven, and we would randomly click something on a menu and look for things that didn't seem right. So in this case, what wouldn't be right? Well, it's a web app, so a 400, a 500, ODBC error. Actually, for this particular client, anything that said error on the page would be a weirdness, because it was one page, I think 1 or 2, a very small number, where you could actually get the word error on the page and it was legitimate. But all the other instances would be weirdnesses. So if we found one that said error, we want a human to go and look at it and go, oh no, that's the one we know about. So we took a different track here. We went with Python and Selenium as opposed to Test Complete, and it took about 3 days to build this. We found 4 issues in just the first week of use. Now, to be fair, this is a target-rich environment, right? We're talking about new network topology, new servers, new all kinds of things. So clicking around, you're going to find something, especially in the first few weeks of a projected migration. Now, why do we go with this solution? Well, we found value at a previous organization I worked with, where it wasn't a menu clicker, it was a link clicker. Much easier, much faster to write the first cut of it. But it showed that something very cheap and inexpensive like this can provide information, can provide exposure to risks and potential issues that we hadn't thought of and that we didn't have time to get to. Selenium was the right kind of toolkit, and that's what Selenium is. Selenium is a toolkit that knows how to drive and poke and prod browsers, and it's great at that. And the fact that it is relatively lightweight when it comes to plugging it into other software. We could take it and do anything we wanted with it. The other tools that we looked at to do this, we could have done it in, but I couldn't get the reporting the way that I wanted it to be. And since it's open source, we had broad license usage. We could run it anywhere we wanted. We didn't have to worry about connecting to a licensed server, which we did with Test Complete. And then we didn't have to compete with licenses with Test Complete. Well, am I going to run SCUD? Am I going to run MIRV? What's my mix going to be when we do a migration? No, we can run the SCUD anywhere. We can run on our desktop at that point. So I worked with a financial company one time, and we created an ACH File Checker. ACH stands for Automated Clearinghouse, and you'll see this on your bank statement sometimes. And long story short, basically it's how the electronic funds get moved from place to place. And there's this very strict and well-known format for ACH files, but it's very flexible in what you have to specify versus what you don't have to specify. And one of the products they had would actually generate ACH files. The way they were testing them today was they had one person spot checking the highly critical pieces. If one of the highly critical pieces didn't look right, then they would spend a little more time on that particular file to see. But it would have taken hours and hours every time they wanted to run these tests to do all these ACH checks. So what we wanted to do was build it into their automated smoke suite so that when they ran smoke tests or smoke automation, they would get the ACH file back and then run a compare on it. But the funding was cut and the project had to end early. So we had this parser and checker mostly working, but it wasn't baked into the framework yet. So this was set really to become shelfware, but it seemed kind of silly. So what I did was I created a command line app to perform this part of the testing. We just took all that parsing and stuff that we'd already sunk a lot of effort and testing into and snapped it into this command line, and took about a half a day to do it. Was it perfect? No. I mean, now what you would have to do is you'd have to go and get the ACH files, but instead of looking at them with your eyes, you ran this parser checker on it, and it would look for anything that didn't match the appropriate format. This was cheap and fast to enable this value that we already had this potential value. We were just not going to be able to realize the value without something like this. And one of the core pieces of automation, when we talk about automation in my world and automation assist, is that something's better than nothing. If we can get 90% of the way, but we can't get to the last mile, we're still 90% of the way. It's not an all or nothing proposition. So setting the Wayback Machine to something even more previous, I worked with a different financial company. And we were sort of a stock trading company, and the team I was on was called Data Networks. And we had the piece that was most closely, logically, to the exchanges. So whenever we would connect to the exchange and all the stock data would start coming in, we would slurp it in and hand it out to the rest of the system. The piece that did that was called the data server. And the regression testing between software versions was effort intensive, because the way it would work is we had a little testing UI. So you'd bring up the testing UI connected to the old version, then the testing UI connected to the new version. Then we'd type in a symbol in one and type in the same symbol in the other, and then try to click the go at the same time. And then you would have to look at like 7 or 8 different fields to make sure that they all matched, and did that for about 100 symbols. And it took about 8 hours of work to do this. In some cases, we could play previously run data through the system, but some of the exchanges had encrypted data, some of the exchanges had encoded data, so we couldn't always do that with all of the exchanges. So I looked at this and said, this is something we've got to be able to automate this, because it's just checking data. So we wrote a comparison tool to connect to both servers and compare. Took the time to test to reduce from 8 hours of effort, which let's say that's somewhere between 10 and 11 hours of duration probably. I mean, nobody can really sit and do this one day straight, to a minute. So not only do we realize a huge reduction in opportunity cost, we can now take releases of the data server more often because the initial testing of it had shrunk down to a minute. So we did this with a C++ program, and I don't remember how long it took to do the implementation, but I remember one of the slides said we were going to break even with that effort after about 6 weeks. So why do we go with this approach? Traditional test scripts were not appropriate. Typically in traditional, you know what your answer is going to be, your oracle, or you're going to compute your oracle. In this case, we were dealing with changing, sometimes rapidly changing stock market data. So we didn't know what it was going to be ahead of time. C++ was the primary language of the company I was working with, and they had an existing API under the product. So it only made sense to use that API and use the language that's primary for the company so other people could work on it and extend it as well. And we found a product bug during just the first execution. Now, that's not to say the testers wouldn't have found that, but what it showed is that, hey, this code is working similarly to how the testers were working for this particular sliver of the testing activity. Now, not all automation has to do directly with testing. Sometimes Automation Assist helps you get rid of some dreck work so you can get back to testing. And in this case, someone I worked with was creating an account creator. So part of her job was to create accounts in these large systems. And it was a pain in the butt. The UI was slow. There was lots of typing, multiple tables to update. The data integrity between the tables was very, very brittle. So if you didn't enter everything in, like if you're going to go straight to the database, if you enter everything in there and missed, one little word here, character there, then the data was going to be corrupt and it was going to be very difficult to figure that out. We also had lots of different test systems. I think there were like 9. So every time we got a new contractor to come in, we would have to add accounts in these 9 different test systems. And during that time, we were rolling in and out contractors fairly quickly. And I don't remember exactly why, but we were. And she was spending a lot of time doing this work. So what she did was she used the Selenium IDE. Record and playback. Oh my God, record and playback's terrible. Not necessarily. We'll get to that in a minute as well. And I was like, hey, how many days did it take you to do this? It's like, a couple of days. But what she did was she basically saved 20 minutes per account entry. So times 9, that's almost 200 minutes of effort savings and duration savings, per contractor coming in. It was very easy to automate via the UI. She had a programming background, but she's like, I've got this tool here, and why not use the record and playback? Well, record and playback's terrible because you got to re-record every time. Not on this interface. This interface had not changed in 5 years. So the likelihood of having to maintain the generated code and re-record or jack around with it was very low. It was a very good risk to undertake. And like I said, it was hard to automate via the database. And she had a coding background, but it wasn't her forte, and it wasn't her core competency at the time. She was the test lead. She wanted to get back to leading the testing. So here's something that's fairly recent, an equivalence checker. So working with a client that is replacing a piece of middleware, and they are very, very sensitive to making sure that there is no customer impact. So it has to be like for like. There, quote, can't be any bugs, which we're going to have a talk about that at some point. But the idea is we want to minimize the customer impact as much as we can. So we're doing a lot of work figuring out what the testing scenario should be, what data we need access to be able to check all these things. But there's a proposal floating around that in order to even further reduce the risk of behavior differences, we want to grab the most recent production requests. So all the requests are stored in a database. Go and grab the most recent X 100, 100, 200, whatever. Run them against the existing implementation, then run them against the new implementation, compare the results. They should be exactly the same. maybe plus or minus some current date stuff, but basically they should be exactly the same. This is still under consideration. We haven't gone through an effort estimate on it. It is not going to be too straightforward to do. It's going to be some work, but we're going to be able to leverage some code we've written for the more traditional automation as well. So why would we go with this solution? Well, this is related to something called functional equivalence testing, and it's a facet of high volume automation. So there's some traction there, but it would exercise valid cases that were not previously addressed, either because we didn't have data because it's only in production, or because we hadn't thought of that one. And we could repurpose the existing automation implementation, build a different harness around it, which would reduce effort and cost and make it something that might be something feasible to do from an economic standpoint. And then the last example we have here is something I call the zero remover. And when I do this in front of people, I usually ask people to raise their hands if they think it's a good idea to automate something you're only going to do once. And people figure out it's a trick question. You get a couple of hands that say no, and some people say yes, and a lot of people just staring blankly at you. But here's the premise. We had a separate kind of tool. And what it would do is it would run a bunch of calculations through this one calculation generator, and then compare all of the responses to these golden files. Thousands of golden files. But there were some code changes made in the product, and in some cases, instead of returning $0.00, it's now returning null. So the test lead and the test architect came to talk to me and say, yeah, we have this problem. And they explained it to me. And they said, we think it's going to take 4 to 6 weeks of effort to go through all these files and identify the cases where we should change 0 to null and then retest everything. So after I got up off the floor, having fallen out of my chair, I said, no, that estimate can't be right. Let's pretend it's just 2 weeks of effort. Maybe we can create something that will do this conversion for us. And that's what we did. We wrote a program to do the file transformation. Well, wait a minute. Why is it only going to take 5 hours to build this program, but it was going to take weeks and weeks of effort for the humans to do it? Well, number one is speed, but also number two, computers are really good at things that humans are bad at, and vice versa. There was going to be some very tedious, very minute work to figure out, okay, is this one of the cases that needs to change from null to 0? Once we worked out what that algorithm was on the board, it was very easy to code. It was very, very easy to code. So why do we go with this particular solution? It was disposable. Outside of the testing, it ran once to do the conversion. So I did it fast, I did it cheap, knowing I was going to throw it away. We were Windows and .NET shop, so it made sense to write it in C#, but it was an easy to distribute executable. I could have probably done it even faster if I'd have done it in Python or Ruby, which I knew better than C# at the time. But then I didn't know who was going to run it. Is it going to be some of our offshore team running it? Is the lead going to run it? Is the architect going to run it? Am I going to run it? But this way, I could just build it and plop it out on a file share, and then anybody could run it that needed to. So we talked about effort, and all the slides here and all the examples had some mention about effort. So effort calculation is a funny thing, because once you have a new tool, yes, the thing you were going to use the tool for, you can now do faster and or better. But maybe now you can do other stuff too. Maybe you can use the tool more often. Maybe you can use the tool for different things. So figuring an effort calculation and a value proposition can be difficult if we go about them from these traditional means. We like to talk about ROI in automation. ROI can be very difficult to calculate because now you have new opportunities to exploit. And plus, if you listen to Don Haynes, and I do, and I highly recommend this blog post, I recommend this blog post every chance I get to anytime we start talking about effort and ROI, and that there ain't no ROI in software testing. And she's right. There's no ROI because ROI is a very specific financial thing. And that's the core of her article here, is that if you really want to get into the numbers and financial aspects of testing and automation, what you really want to do is a cost-benefit analysis, not a return on investment calculation. But I'll leave that to you to go and read. Sometimes when we talk about value, we can use the term opportunity cost, which also means something to the financial people. Opportunity cost, very, very briefly, is the cost of not doing activity B because you're doing activity A. So if you're fixing a problem, you're not writing new code. If you're writing a new feature to do one thing, you're not writing the new feature to do the other thing. And the thing you're not doing was either going to help you make some more money or reduce your cost, or both. So there's a cost to not doing work. We can talk about automation and automation assist as reducing the opportunity cost, because now we have the machines working on what they're good at, so the humans can work on what they're good at. And we have to focus on value. As soon as we start talking about anything that's not value, we run the risk of doing stuff that might be neat, it might be helpful, but it's not producing the value we would like. So the other thing you'll notice about all these examples is that they're all about coding. But damn it, Jim, I'm a tester. I'm not a programmer. I don't know how to program. I don't want to program. My answer is so. So what? Just because you don't know how to program, that doesn't mean you should not be able to enjoy the advantages and the benefits of automation. So most of us have used a command line before. If not, go look at what a command line is, because a command line's your friend. It can help you do things that other programs either can't, or you don't have access to the other programs, because there's lots of built-in text and file processing commands built into pretty much every command line that you use. And then you can chain these commands together to do more intricate things. So let's take an example. What we want to do is we want to go through a log file and find all of the instances where a transaction timed out and it was therefore incomplete. So here's our example log file. And as you can see, we've got some completes, then we've got some timeouts, but then we've got a few that are also incomplete and timeout. Those are the ones we're interested in. You say, well, Paul, you got like 30 lines in here. Why would you write a program or use any of these tools to go through and pull that out? Yeah, okay, there's 30 lines here, but what if there were 3,000 lines? What if there were 30,000 lines? What if you had 1,000 files that each had 1,000 lines in it that you had to go through and grab these pieces of information out of? That's where the power of these tools can come in. So close to getting it right on our first try. So here we use a command that's built into the Windows CMD, the command prompt, called find stir. And what it says is, hey, go and look for this string, this set of characters in the file that you give me. And what does it do? We said, hey, go and look for incomplete in the file. Well, it found all the instances of incomplete. However, there's one that says incomplete and canceled, and we're not interested in canceled. Again, you say, Paul, why are you going to fool with tools? You've only got 4 to look at. Yeah, but what if I had 400 to look at and they weren't so neatly formatted as this? So looking for incomplete didn't get it for us. Maybe we should look for timeout. So look for timeout. Yeah, we got the ones we wanted, but we also have these other timeouts for some other log message. Not what we want. Man, it would be nice if we could take those and sort of get the results of both of them as a filter. Fortunately, most command lines have a way of doing this, and it's called a pipe. And it's a way of chaining commands together so that the output of one command goes to the output of the other command. And a pipe is almost always that vertical bar you see there. And the way you would read that is result of command A is input to command B, and so on and so on. They can be chained quite long. And really, this is supported on most command prompts and shells. So here's how we get this done. What we want to do is we want to call find string, get all the instances of incomplete, but then take those instances and look for just the ones that have timeout. So you'll notice we have our pipe there, also called the vertical bar, and it finds just the ones that are incomplete and timeout, which is what we wanted. Now, this is cool and all, but nobody wants to type that in every time. And it's going to be hard to manage if you have this file that has just a bunch of these commands that you're going to copy and paste in each time. So what we can do is we can put it to live in its own file. Specifically here, what we're looking at is a batch file, a Windows batch file. And we're just take the text that we had there, we plop it in the file, and we can run it anytime we want. However, it's a little restrictive right now because you'll notice we've hard-coded. We specify the exact file. What if I wanted to look in a different file? Or what if I wanted to look in 50 log files? Fortunately, the batch file allows us to do that. So here, I apologize. I think that's the organizers hassling me on time. So here we can use this little symbol, and I'm not going to go into any sort of deep training on batch files here. There's lots of documents and training out there. But what that says is take everything from the command line and shove it in this spot. So when we go and execute, you'll see we're running our find incomplete file, and we're saying, hey, feed it all the files that match parent, log, and then some other stuff. And you can see we get multiple results that way. There are examples for other shells as well, such as PowerShell. Instead of find stir, it's called select string. And for Unix, Linux, Bash, macOS, it's the command called grep. So I ask you, is this not automation assist? Sure it is. It helped us process some stuff for our testing. Wait a minute, we put it in a file. Is that not a script? I submit that it is. Didn't we just program? Boom, now you're a programmer. Programming does not require a bachelor's or master's degree in computer science. Programming is just something you do. It's another tool you learn. So again, in the interest of time, there are some interesting tools here. I assume the slides will be sent out, but if not, take a quick screenshot of this because I'm not going to go through each one of them. And then we'll go to the takeaways and take some questions. So this is different. This is different. If you go to a job interview for an automation role and you start talking about all of this, most of the hiring managers are going to say, that's cute. Do you know Selenium, or do you know test completed? Do you know UFT or whatever? Not everybody is thinking about this broad definition of automation. Instead of thinking of automation in terms of test cases and stuff, let's think of it in terms of judicious applications of technology to help humans do their job. There's nothing wrong with scripting scripts based off of your existing test cases. But that's only one implementation. That's an implementation. That's not what automation actually is. Situations will help you. Remember, the knowns will help guide you. Your ecosystem, who's going to run it? How are you going to hand it out? And is it disposable or long-term? Disposable, quick, dirty, record and playback sometimes. Or long-term. And remember, the command line is your friend. So don't be scared of it. Try some stuff in it next time you're looking to dig through some files or something. And now questions. So I guess Eric or Valerie, over to you. Okay, Eric is joining now. So I guess if there are questions, you can put them in the chat there, and I will see them. Do I think automation saves time or allows more to be done within a time period? So thanks for the question, Richard. I think yes and no and maybe. So what we need to do when it comes to automation is we shouldn't think of automation as a separate thing. We should think about this as part of delivery. And software creation and delivery should be in direct line with whatever your corporate goals are. Do you want to get to market faster? Do you want to reduce your defects? Do you want to get into a new market? Whatever. The software development needs to be in line with that. The testing needs to be in line with that. And the automation needs to be in support of that. So in some cases, it might be that automation is going to save you time, like in the case of the account creator, or allow you to get more done within a time period. Then MIRV, the parallelized execution of tunneling through the web pages, might be an implementation that's interesting. So it's not so much what does automation do, it's where's your pain point, where's your opportunity, and can computers help you close the gap on that opportunity? So there's no set pat answer for that. And we have a question from James. What would characterize situations where you would or would not reach for automation? Non-deterministic things, I would probably steer away from automation. Things that are very rigid, very repetitive, very detailed, but are also quantifiable algorithmically, those are typically good cases, good circumstances and situations for automation. But again, it's not a fell swoop, because what would work for me in my context isn't necessarily what I would advise to you in your context. It really is a case-by-case basis. But generally, anything where the results are fuzzy, the results are hard to quantify, that there's a real human impact to it, right? I mean, if we're doing calculation, yes, okay, the calculation's got to come out right. Computers are really good at calculations. So anything that's sort of calculation related, I probably wouldn't have humans doing the brunt of the work there. But anything that's going to be more artsy, visually appealing, like, does this look nice? Does it feel nice? Am I angry when I use this product? Those are things computers can't tell you. I actually interviewed with a gaming company one time, and I talked about, automation is good for some things, not other things. And the recruiter actually said a line, it's like, you can't automate fun, can you? Like, no, you cannot automate fun. That is a human thing. That is an emotion, an activity that computers just don't have. Okay, let's say I work on a legacy project that is still evolving. Automation Assist is what I've been calling test support. Good for you. Awesome. And we use it a lot to set up data for test cases. Yes, 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 yes. A lot of times we so often get focused on, okay, I need to write a smoke testing automated suite. Well, you might need that, but you might get more benefit by doing that second and dealing with your test setup and your test data setup and generation and maintenance first. So awesome for you. As we progress in DevOps, we've been pretty successful at shifting testing left and involving more of the team. The question, who's responsible for maintaining the tests? Any thoughts? Yes, everyone is. Everyone is responsible for maintaining the test, because software delivery is a cohesive team activity. Now, are some people going to be better at it than others? Yes. Are some people also going to be better at programming than others? Yes. So everyone is going to have a discipline, a set of skills that is going to lend itself better to some activities versus others. But in reality, which team maintains those scripts and those tests and stuff, it matters such that people need to do it, but it doesn't matter from a team name or department name, as long as the appropriate due diligence is being put toward it. So that probably didn't answer your question very well, or probably not the answer you wanted, but that's where my brain is when it comes to that sort of ownership and responsibility. So, okay, that was Kathy. Thank you, Kathy. Next question after Kathy is from Peter. Are there particular tools that you would recommend for automation assist? If you look back at all the things that we used and all the examples here, you'll see that there's not really a pattern there. And that's because when you're doing something that's automation assist, it's taking something that you have already or something that's appropriate or almost meets your needs and then bending it to your will to get it to do those things that you need. So we used Selenium, Selenium IDE, Test Complete, a few homegrown, homemade tools. So there's nothing that I would say that, wow, this tool is great for automation assist. What I will say is that the more narrow the focus of the tool, so something like Selenium, and not just Selenium, but others that do sort of browser poking. That's all they do is browser poking. They don't deal with mobile. They don't deal with databases. They just do this one thing. Typically, those are easier to bend to your will because they're not worried about creating a solution and a big ecosystem for you. They're worried about action, response, stimulus. And in fact, with Selenium, it doesn't even care about stimulus, response, check. Selenium doesn't even care about the check. It's all about the stimulus and the response. The check is something you create. So very, very thin tools and narrow tools like that tend to lend themselves better to automation assist, but that doesn't mean more broad solution-y type tools cannot be used for automation assist.
Great. I've managed to get myself back on screen. So let's go to the next question, which is from Richard. Would you say that automation assistance is a DevOps-like activity? And as a follow-up, what skill set is needed?
Okay, so would I consider this a, Eric, you go on mute, please. Okay, so what I consider a DevOps activity. So it depends on how you're defining DevOps. If you're defining DevOps as a culture and a way of working together, that happens to have some tooling out there for it, then absolutely it's a DevOps activity because DevOps is really sort of the evolution of automation and of software delivery beyond agile software creation and delivery. It's a more broad ecosystem and a more broad audience participates in it. So who types the keys? It doesn't matter. It really doesn't matter as long as the ability is there for the person typing the keys. Now, who comes up with the ideas for automation assist? Well, in our world, typically it's going to be the testers because I'm very testing QA focused, but that doesn't mean I haven't built tools for testers, for developers. In fact, the project I'm on now, the developers are writing all the automation. Or, well, let me be more specific. They're writing the automated scripts. I'm writing some framework code. And then the other couple of testers that are on the team are helping assist with creation of the scenarios so we know what we're testing, and then managing with the test data so that we have the appropriate test data to exercise those. But if we're talking about DevOps as I'm a DevOps engineer and I'm doing Jenkins and I'm connecting these Tinker Toys together and I'm making sure that all the tools work together and being, even extending into site reliability engineer. Again, the answer doesn't matter who types the keys, but at that point, it's probably not their forte to be able to do that because it's not typically the tool set they work with. But that doesn't mean they can't.
What I would add to this is I think that testers can be highly technical even if they don't crank out automation. Being able to run queries, being able to use the command line, some of the ways that Paul showed us, testers can make themselves very effective. I've been the happiest working in teams where the person who would do a task would be the person, whoever was qualified to do that. And for the most part, there have been enough problems running around that needed somebody to work on them that it's been pretty unproductive to worry about. Well, QE doesn't do that, and engineering doesn't do that. But that would get into I think that would get into a larger conversation about how your teams are organized and how they work together. I don't think that's usually a healthy sign if people feel like they're not allowed to do a thing that would help the team.
Agreed.
I think testers need to find a way to help a team, and sometimes that's direct examination of the software. Sometimes it's working on things like how many failures do we have in our log files. I think that's how you make yourself an effective and useful tester to your teams. Okay, we have one question left queued up.
Awesome.
Where Richard asks, do you have a cheat sheet of command line commands you use or recommend?
So no, I don't, because I've been doing this for so long that some of it just comes natural. Especially if I'm working on a Linux environment, because that's my first 16 professional years, and all of my college years were some flavor of UX. So I'm very comfortable with that. Usually what I have to do is I have to go to Google and say, how do you do grep in in Windows, or how do you do a tail -F in Windows, and figure out what those are. Excuse me. What I would suggest is looking at some of the tools that I put up on that other slide. Actually, let me go to that real quick. Whoops.
Very quick. We're down to our last minute or so.
Okay, well, I don't have time to do that. But so type, redirect, anything that lists, anything that looks for applying patterns to find something in a file. Those are the things I usually use command line for, because it allows me to work on things that maybe a text editor is harder to do, because you can do multi-step. Unless you're very familiar with the macro capability in a text editor, and then maybe you'll just be better at that. So it's not that one's better than the other, it's whichever one you're comfortable with. And you're very welcome.
Ken. We've reached the top of the hour. I really appreciate everybody coming and asking questions. I really appreciate Paul giving us such a useful talk. I think there's a lot of practical things we can use, and I'm glad that it's helping you with confidence, and hopefully gives you confidence to attack some of these technical problems on your own. So next month, our virtual event is going to be an online tutorial, test automation strategy with Janet Gregory. Yes, that Janet Gregory. She will lead an interactive workshop limited to just 12 people. It's tool agnostic and somewhat focused on agile contexts. If you're asked to create or run an automation program, this tutorial might be very helpful for you. So we have a sign-up link in our latest newsletter, and we'll certainly be tweeting about it and giving you a chance to come into contact with that. That's something to look at. And then later on this year, we'll see more events like this and some things that aren't exactly like this. So thank you all for coming, and I hope we'll see you next time.
Thanks a lot, everyone.